In this session, we will learn to remove complete electrolytes from a lead-acid battery and refill. At the end of this session, you will be able to describe the importance of battery maintenance, explain the relationship between electrolyte quantity and charge storage capacity, and describe the steps in draining and refilling electrolyte in the battery.
Battery maintenance is well recognized as an important part of running an efficient and safe warehouse. However, the appropriate procedure for battery maintenance is often overlooked. Performing maintenance in the correct order is just as essential as the maintenance steps when it comes to saving time, extending the lifespan of your battery, and protecting your equipment. Moreover, establishing the appropriate procedure for battery maintenance is a vital part of maintaining a productive and safe work environment. Charts and maintenance schedules are a good way to ensure that batteries receive the appropriate maintenance. Let's briefly go through common defects in batteries. There are short-circuited cells due to failure of the separator between the positive and negative plates, short-circuited cell or cells due to a buildup of shed plate material below the plates, sulfation after a long period of disuse in a low or no charge state, corrosion or damage to the positive and negative terminals, broken internal connections because of corrosion, broken plates due to corrosion and vibration, damage to the battery case, and low electrolyte level. In the next section, you will see the relationship between electrolyte quantity and charge storage capacity. The charge storage capacity is the total amount of electricity a battery can store. You may have seen that lithium battery storage capacity is described in mAh or milliamp hour rating, and in the case of lead acid battery, it is amp hour. This charge storage capacity is highly dependable on the electrolyte quantity or active material and the plate's size. The electrolyte is water and sulfuric acid. Maintaining the appropriate electrolyte quantity is essential to facilitate the chemical reactions, charging and discharging. Insufficient electrolyte quantity reduces the battery performance and causes battery sulfation. Here comes the procedure to remove electrolyte from a lead-acid battery and refill. Ensure you have all the following tools and equipment: rubber siphon, glass beaker, funnel, hydrometer, diluted sulfuric acid, and lead-acid battery 12 volts 100 ampere per hour. Wear hand gloves. Using rubber siphon, drain out electrolyte from the battery kept at higher level to the glass beaker and the glass beaker at the lower level. After emptying, check the anodes and cathodes for any cleaning requirement. Use light grade emery sheets and scrub the electrodes. Reinsert them. Using a funnel, pour the diluted sulfuric acid inside the battery till the electrodes get fully immersed. Check the density. If the density is higher, add distilled water to get the right specific gravity. Finally, record your observations. Please note, all personnel working with batteries should first be trained in the proper lifting and handling procedures. Also, it is a good practice to regularly remind workers of appropriate battery handling procedures to maintain a safe working environment.
We have reached the end of this session on to remove complete electrolyte from a lead-acid battery and refill. By now, you should be able to describe the importance of battery maintenance, explain the relationship between electrolyte quantity and charge storage capacity, and describe the steps in draining and refilling electrolyte in the battery.